What is going on, meteorology students? This is a slide video presentation over types of chemical reactions. We are at the very beginning of this chemical reaction unit, the fourth unit, and I want to walk you through the dating scene. This is a relatively straightforward and slightly awkward way to help you identify which types of reactions are taking place. Now keep in mind, when you look at a chemical reaction right now, it's going to look a little bit crazy. It's going to look like a whole bunch of stuff from the periodic table just got thrown up into one chemical sentence. That will slowly start to make sense. So this is a bit of a stretch for us to jump into right away unless we had something like the dating scene to help us make sense of it. Okay, so here's how it works. When you see a type of reaction or a chemical reaction, we want you to be able to fit it into one of about 5 categories. And here are the categories. The first one is the story of boy meets girl and girl likes boy, right? What in the world does this have to do with chemistry? Well, everything. Don't relationships have a ton to do with chemistry? We're looking for patterns. This is all about pattern recognition. So know that A is not an element on the periodic table. B is, but that's just by chance. What we're trying to show you here is when one element or molecule is added to another element or molecule and they combine together. We call this an addition reaction. Okay? Sometimes it goes by slightly other names like a synthesis reaction. We're going to call it an addition reaction. This is the type of story in Hollywood. This is like a Hallmark movie. Nothing wrong happens. The boy meets girl, girl meets boy, they hit it off, and they get together, right? So this is the type of chemical reaction that would show you or be an addition reaction, right? We have iron here. It's being added to the sulfur here. You don't have to worry too much about the numbers that are going on, either the lower ones or the coefficients over here to the left of the numbers. But notice how after the reaction takes place, this product over here shows the iron and the sulfur together. Oh, happy story, right? It brings a tear to your eye. This is an addition reaction, okay? Now, there's another story. This one's sad. This is the type of plot where some people just like misery and unhappiness in the world. A and B are together. If they start off this way, this is the left side of the reaction. This is the breakup, okay? If A and B end up breaking up and at the end of the reaction, they are two separate things. We call this one the breakup or the decomposition reaction. When you see a chemical symbol like this, we start off with water on the left-hand side, okay? And it breaks apart into hydrogen by itself and oxygen by itself. Notice where the arrow is, okay? Those two things started together but were broken apart. So not all chemical reactions involve putting things together. Some of them involve breaking things apart, and we call that a decomposition reaction. Here's the next story. This one gets a little bit more complex, right? Let's say that A, this single gentleman here, he's the nice guy. And he's got his eye on the girl over here, X, okay? But she is currently together with this gentleman, B, who's not a nice guy, okay? I know he looks like a super nice guy, but he's not. He ignores her. Maybe he's obsessed with running or biking or his career and doesn't have time to spend with X. And so what happens throughout the course of the movie is they break up. Okay, B and X separate. And notice how the nice guy now gets the girl, right? This is also a little like a Hallmark movie. And we leave B over here all by himself, wondering what in the world happened. Maybe he should have spent a little more time with his girlfriend, and then she wouldn't have broke up with him, right? This is the dating the wrong person scenario, and we call this single replacement. Okay, single replacement. A starts off single, and after the reaction, it's bonded with something else, right? It's how it should be. And the B and the X that were together, they were broken up, and B is left all by itself. We call this single replacement, all right? Here's an example of it down here below. Take a look at zinc. Zinc is all by its lonesome over here. But after the reaction, after the arrow, notice how zinc is now paired up with chlorine, right? But chlorine started off paired up with hydrogen, and they broke apart, and now hydrogen is all by itself over here. This is called single replacement. All right, now this next relationship is all sorts of crazy, right? This next one is two unhappy couples. We've got A together with X, and we have B together with Y, but nobody's happy, right? They met and they got married. Maybe it was an arranged marriage. Maybe the families just pressured them into it. Maybe so-and-so married so-and-so because they were a doctor or a lawyer, or there was security, or maybe they were just really good looking. But the bottom line is these two couples are unhappy. And so what happens is they split, okay? A and X split up. B and Y split up. And at the end, I know they still look angry, but trust me, they're happy on the inside. They have found each other. A and Y make a better match, and B and X make a better match. And we call this double replacement. This is one of those crazy relationship type movies where everybody's breaking up and getting together and breaking up and getting together, and at the end of it, it all just works out properly. But it started off as a huge giant mess. Look at this complex equation. You got to take a minute and break it down. Over here, right, we have sodium. That's like A, this gentleman right here. And that person is bonded with X, which is Cl. On the other side of the equation, though, notice that Na and Cl are separated. They're split up. Okay? And here, the second relationship, Ag, which is silver, is like this guy. And NO3 all together, I know that's a little weird to have them all together, but NO3 all together is like this lady, Y. And so A and Y join up on the other side of the equation, and X and B join up on the other side of the equation. So nothing is left alone. Everybody ends up with somebody, but it's all one big giant switcheroo. That's what we call double replacement. Okay? The very last one I have nothing for. I don't know, the flames of love. I have no idea how you'd relate this to a relationship. This is just a combustion reaction. And the clue for a combustion reaction is there's a whole bunch of stuff going on. But the combustion reaction doesn't really change much from one example to another. You start off with something that has carbon in it. And in the presence of oxygen, because you need oxygen for something to combust or to burn, it burns and combusts and gives off carbon dioxide, water, and some form of energy. Okay? This does not change from one carbon reaction to the next, or combustion reaction, I should say. Okay? Now, what carbon is over here won't always be 1C. It just has any molecule with carbon in it. Burns in the presence of oxygen, and this is what the combustion reaction looks like. Okay? So your task will be in the skill sheet that we've posted for you, 17.3 in Canvas. We want you to take a look at the types of reactions that we've given you. There's a list of 10. And we want you to classify each one as one of these 5 types of reactions. Either a combustion reaction, a double replacement, a single replacement, decomposition, or an addition reaction. Okay? You can use these slides. In addition to this video, I posted the slides just for you to pull up. Try and classify all 10 of those. Okay? Good luck to you.